All right. We are going to do systems of equations, and I'm going to add a little like extra words here, because systems of equations can have lots of different elements to it, okay? And so at least how to find them. And so first we're going to just start off with what this means. A system of things is something that has a bunch of them. So if you had a system, means there's lots of parts of it. And what is this a system of? Many what? Many equations. And so if we have equations, the equations we're going to be talking about are linear equations, ones that graph lines.
Okay.
And so there are many ways to solve and find the answers to systems of equations. And today we're going to do by graphing. And we're actually going to mostly explore the vocabulary that comes with systems of equations, okay? And so we'll start reading here. It says, if two linear equations are graphed on the same coordinate plane, they form a system of equations. And so here we have an example of a system of equations. We have x and y axis here, the x and the y, and we have two lines being drawn. And so these are a system of equations. Mm-hmm. We have another system right here, x and y axis, and we also have another system right here. Okay, this doesn't look like two lines, but we're going to talk about that this is two lines also. Okay. All right, right now it looks like it's only one. Okay, and so equations that are not equivalent but have the same slope, these have the same slope. These are parallel lines, okay? And these have no solution, no points in common on them at all, okay? These here have one part in common, and the point they have in common is right there in the center, okay? And they have one point in common, and that is its solution. Okay, so the point they have in common is called the solution. And they might even eventually ask you to find what that solution is, and you'll just find the ordered pair. Oh, the ordered pair is going to be 1, 2, 3, come out 3 here. And we came up 1, 2, 3, 4, 5, 6. So would be 3, 6. That would be its solution. Okay?
Oh, okay.
All right. This is two lines that are on top of each other. And so they have every single point in common that lies on there. And remember, these really are lines that go forever and ever. And so every single point is in common. There's no way you can write all the solutions to this. They're in an infinite number of solutions. Okay? Mm-hmm. So back here at the beginning, this one has no solutions.
So that means it's independent?
This means it's inconsistent. There's no consistency between any of them. There's nothing in common. And so they will give you the vocabulary inconsistent. Okay, so they'll ask, are they inconsistent, consistent, or dependent? Okay, these were totally inconsistent, nothing in common. These will be consistent because there's something in common between them. There's only one thing. So this is consistent. One solution. If they ask you to find it, it's where they cross. Okay. And this one is dependent. They depend on each other. They're have all the solutions they have. And by the way, this had one solution. By the way, one solution. This has infinite number of solutions. But it's not any solution that you can ever find. It's all the points on this line. Okay.
So, in the other words, would that be dependent?
That would be dependent because it depends on the equation, all right? Okay. And both of them have, eventually, if you were to simplify their equations, they would come out to be the same equation. But they're going to have two different looking equations when they first start out, okay? And once you solve them out, they're going to be this, you'll solve them for y, they would have the same equation. But when they're put in the standard form, they'll look different for a while. And so they won't have any, like you couldn't just pick any ordered pair you so desired. The ordered pairs that would be the solutions would be, in this case, 2, 3 would be a solution. But there'll be an infinite number of them, but it won't be a random infinite. It'll be a specific ones to the equation. So that's why it would be dependent on the equation, okay? Spell that right? Mm-hmm. I did. Okay. So let's go back and review real quick. we have two parallel lines. There's no solution. They don't cross at all. They're called inconsistent because they have nothing in common. They're not consistent with each other. All right?
Right.
This one has one solution. This is what you're going to mostly deal with, at least in the math classes you'll take, would be ones that have a solution somewhere. Okay? These are called consistent in the sense they're consistently have one point. These ones, it looks like one line, but it's actually two laying on top of each other. These have an infinite number of solutions, and they're dependent because they depend on the equation. And there wouldn't be just any random points. They'd be the points that were on those two lines.
Okay.
Okay? All right. We're done?